So those two talks were fantastic. So this is going to be hard to kind of keep pace with those. But what Carrie talked about, excuse me, with vitamin E, I think sets up quite nicely for what I'm about to talk about. And we're going to switch gears a little bit here, and we're going to talk about the effect of heat and what it does in terms of nutrition and the exercised horse. And when we say exercised horse, that covers a lot of ground. There's a lot of different disciplines that we deal with, but they all have the same thing in common. What they do is it's all about locomotion, and locomotion means muscle contraction. And to make the muscle contract, you all know that we convert chemical energy into mechanical energy by first creating ATP. But I think what's lost on a lot of us, including me for a long time, was this isn't a terribly efficient sort of process because there is a lot of heat released. 80% of the energy that's consumed during exercise is actually released as metabolic heat. And that's if the horse is using the energy aerobically. If you get to anaerobic, you can tack an extra 7% on. So horses lose a tremendous amount of heat when they're exercised. And I didn't really understand how much heat it was or how much it changed the muscle. And what we know now is that exercising horses, they produce a lot of heat in their muscle, and their muscles can get quite warm. They can get up over 109 degrees Fahrenheit, 43 degrees centigrade, and at that point, you start to do some things to the muscle. And I think that this has become very relevant. At our last conference in 2024, Mike Davis gave an excellent talk about heat and heat stress in exercised horses, and he came up with this really interesting sort of calculation. And he said that if a horse is going along at just a brisk trot, if it can't get rid of that heat, if it can't dissipate the heat that's being produced in the muscle, that it's got about 2.5 minutes worth of storage supply. So if that horse can't move the heat out of its body within 2.5 minutes, it's going to accumulate to the point of becoming dangerous. So horses have really fine-tuned mechanisms for getting rid of dissipating heat. And really we should look at it like an automobile engine. If you think of the muscle is like the engine itself, in an internal combustion engine, what do? You circulate a coolant, and the coolant is pumped with a water pump. Well, in the horse, you circulate blood to the muscle to remove that heat, and that water pump is the heart. The radiator of the horse is two places. It's the horse's skin, and it's also the surface of the lung where they can get rid of a lot of that heat. So a real important process, though, is to get that heat out of the muscle where you've produced large amounts quickly into the blood, have perfusion from the blood to take that heat to the skin. And it's at the skin, there's several different choices that you can have for how you get rid of this heat. But these are very important components of heat dissipation is the perfusion to the skin and then getting it from the skin either via water or air away from the horse. So a horse actually has several different sort of natural ways that it can dissipate this heat. It can do it with respiration from the lungs. It can do it by convection, by air currents going past it. It can do it by conduction, so if there's water on the skin or even air on the skin, it can take some of that heat away. And the most important one is via evaporation. If you look at which of these are really important for the horse, respiration's actually, during vigorous exercise, is an important way for the horse to get rid of heat. If you think about it, the blood is being circulated to be reoxygenated in the lung. At that point, the blood is hot. It's been in contact with the working muscle. That hot blood has come to the lung. And as the horse exhales, a lot of that heat leaves with the exhaled breath. And it's been calculated that about 15 to 30% of the total heat that the horse will dissipate during exercise comes via respiration. Only 15 to 30% of the energy, of the heat. Dogs, on the other hand, depend almost entirely for panting to dissipate their heat. So they've adopted not by evaporation with sweat, but by dissipation via the lungs. And so they're really good at moving the heat from within the blood into the lungs. That's not the strategy really that the horse adapted. Really what the horse adapted to was to use sweating as its main way of dissipating heat. And really, horses are kind of by themselves in their ability to produce sweat. Surprisingly, there's not that many different animals that produce sweat. We produce sweat. We're one of the animals that does. But most animals don't use sweating as a main way of dissipating heat. But for horses, it's the main route of dissipation. And they sweat more than any other animal. And they've got some special adaptations that allow them to produce a lot of sweat very quickly to cool the animal. So it's estimated that it left to its own means, if the humidity is low enough, that 70 to 75% of the heat that's lost from an exercised horse is going to be via sweat. And so this was the primary mechanism that horses chose to dissipate heat. Well, why did they do that? Why did they use sweat, and how do they actually do it? Well, you have to look at how a horse evolved. They're large-bodied animals and they're prey animals, so they were being chased around. And so to avoid capture, really what the horse needed to do was prioritize survival. And the thing they prioritized was to prevent hyperthermia, because that was the number one danger to the horse, was to get too hot. And so they had to develop some sort of mechanisms that allows them to move a lot of heat very quickly. And what they chose to thermoregulate was sweating. But they did it at a real cost. They did it by losing massive amounts of electrolytes in their sweat. It was done purposely to help produce sweat, help eliminate sweat, but it's something that also causes some issues in terms of electrolyte losses. Well, if you look at our sweat, we use exactly the same mechanism to produce sweat as a horse does. Neither humans nor horses actually actively secrete water into sweat glands. What they actively secrete are electrolytes. And the primary electrolyte that's secreted is chloride. It's followed by sodium, and then the water follows that. The difference, though, is that humans want to preserve those electrolytes. And so we have much more complex sweat glands than horses have for resorbing the electrolytes that were used to create the sweat to begin with. So in a lot of respects, our sweat glands are like the kidney, in that the ability to actually recycle these electrolytes. And so human sweat typically is not nearly as salty as horse sweat. Horses, on the other hand, they said, we need to keep cool, we need to produce lots of sweat. The way to do it is produce a lot of secrete a lot of electrolytes. The water's going to follow the electrolytes, and the sweat's going to go away, but it's going to be salty. So again, how do electrolytes help sweating? Chloride is actively secreted into the sweat gland. That creates the hyperosmolality that has water follow behind. Sodium also follows, though, down an electrochemical gradient behind the chloride. Both of those combined make it even more osmotically dense, so that it amplifies that osmotic effect. There's potassium as well that goes into horse sweat, and that's done almost accidentally, because potassium actually, there's not very high in extracellular fluid. It's more of an intracellular electrolyte. But the horse's sweat gland is made so that there are some blibs of the cell contents that go into the sweat gland releasing some potassium and some other things that are important for sweating that I'll talk about in a second. So if we look at the difference in electrolyte concentration between plasma and sweat, there's a big difference between what goes on in people and what goes on in horses. On the left side, I have horse plasma, which is in yellow, versus horse sweat that's in orange. If we look at sodium, they're about the same. The amount of sodium that's in horse sweat is about the same that's in the plasma, so it's isotonic to the plasma. If you look at chloride, though, there's a lot more chloride excreted into sweat than is actually in the plasma, so it's hyperosmotic, hypertonic. And then there's more potassium. And if you look on the right at human plasma, you see there's no potassium, there's very little that's lost, and there's a lot less sodium and a lot less chloride that's lost. So horses developed this plan that they weren't going to worry about losing these extra electrolytes because that increased the osmotic difference, and it drove water and it drove sweat production. So if we look at kind of the typical concentration of these electrolytes in plasma, you see chlorides 5 to 7 grams per liter. That's the liter. That's the one that is being pumped out actively to make sweat form. Sodium follows behind at 3 to 4 grams, and then potassium again is there sort of incidentally to that at about 1 to 2 grams per liter. So if you look at common electrolyte supplementation, they typically follow this type of recipe. So when we're trying to produce an electrolyte to replace what's lost in sweat, we look at these compositions. We take into consideration the digestibility of each of the minerals, the bioavailability of them, and concoct an electrolyte mix. And so these are the types of data that are used in producing that kind of information. Now, the interesting thing about sweating, though, it's a great job of moving a lot of heat, but it only works really well when the temperature and humidity are low enough to allow the sweat to evaporate. And that's a real important concept, and we've learned that humidity particularly becomes a real determinant of how well a horse can actually sweat. I have to say I'm proud to live in the two horse capitals of the world, Lexington, Kentucky, and Ocala, Florida. I guess they both decided that they were going to anoint themselves as horse capital. I've got arguments for both of them. I think they should share the title. But they're very different in terms of environment, and we need to take into consideration the environment when we're looking at cooling. This is a graph, and this is a really cool representation of the average hourly temperature in Lexington through the year. So if you look on the x-axis, that's the month of year. The y-axis is the time of day, and then it's color-coded how cold it is. And so the darker blue is freezing, dark green's very cold to comfortable to warm. And you can see how that changes across time. I put this red arrow or red line to show kind of where we are right now in late March. And as you can tell, it's not bad. It's fairly comfortable, cool in the morning, and it's not a bad place to be in Lexington. And if you look at the horse events that happen in Lexington, you can see this is when the 5-star Kentucky 3-day occurs, is in late April, and you can see that it's still quite cool and comfortable. There's where the Kentucky Derby occurs, and you can see it's also quite comfortable. So this is sort of the way that things look in Kentucky this time of year. Let's contrast that to Ocala. And Ocala, even though it's the other horse capital of the world, is the hot horse capital of the world. You can see where we are now. We witnessed the last couple of days, late in the afternoon, it's getting up to where it's fairly hot in the afternoon. Well, everybody's adjusted to this, and where do we have WAC? We just had it. So it's when it's in these cool temperatures that we typically are down here. So these are temperatures, and this website's called weatherspark.com. You definitely should go there. You can put any city in the world and see this information. This is heat that I'm talking about. Let's switch now and look at humidity. So this is humidity in Lexington. And so again, the red line is where we are now. There's where the 5-star is and where the Kentucky Derby is. And you can see that it really doesn't start to get muggy until later. And they kind of had a cutoff here of May 24th, where 16% of the time is considered muggy. And this goes through the summer. In the height of the summer, June, July, August, you can see that it gets to be muggy. And even there's a little bit that's oppressive. So even in Kentucky, in the summer, in the middle of summer, there are some times when it gets pretty uncomfortable and fairly humid. But, as they say, Ocala would say, hold my beer. Because this is what Ocala looks like. If you look at the humidity in Ocala, and again, this is where we are right now, they say come May 7th is when it starts to get about 26% of the time muggy. And that lasts clear till October 29th. And I love the descriptions they have because they go from muggy to oppressive to miserable. So if this is a Chamber of Commerce ad for Ocala, visit Ocala in July and August when it's miserable because it's so hot and humid, which again is why they have the shows in the dry part of the year. Well, what does that heat and humidity do to sweat production? Well, it's a big problem, and again, humidity is a real problem because sweat, if it evaporates, takes a lot of heat with it. If sweat drips off the horse, only 5 to 10% of the heat is captured and released. So there's a real big difference between the sweat actually evaporating and sweat dripping off. But the horse thought of that because one of the things that's put into horse sweat, which we don't have, is a protein called lathern. And that's where the little blip comes that causes the potassium in horse sweat, is this protein lathern is also secreted. And it's produced by these same sweat glands, but what lathern does is it reduces the surface tension of water, it allows the sweat to penetrate the hair coat, and it enables evaporative cooling. Now the picture I've got here is of a horse where you can see the lathern up under the leather there, and a lot of people see that and think that's a problem. It's actually not a problem at all. It happens in all horses. They produce lathern. It's just if you rub on the coat, it will become foamy. This is actually distributed in all horse sweat, and it's a good thing to happen. So how much heat a horse produces and how quickly it can get rid of it is actually something that's really important. And it's something that we started to study down at our research facility here in Florida and then later in Kentucky. Now the problem with measuring how much heat a horse is producing, particularly in the muscle, is how you actually measure muscle temperature. Historically, and there was some really good studies that were done with it, but they used thermistors connected to wires that were put into horse muscle, and those were hooked to big machines to measure the temperature of the horse muscle. And that meant that you were kind of chained to the treadmill at that point. You could only do the exercise on the treadmill, and you really couldn't follow the horses around afterwards. Well, there's been a real innovation in terms of allowing us to measure the temperature in muscle. And that's these little microchips. These microchips that are used for identification, that nowadays every horse wears a microchip for identification. They also make these now that'll measure temperature. And these go up to 43 degrees. They're the same as the other ones that are used. Typically, they're put in the nuchal ligament of horses for identification. But a group at the University of Queensland took these microchips and they started putting them in different muscle groups. And the two that they found was best to put these microchips were the gluteal muscle and the pectoral muscle. They found that these were the ones that were most correlated with changes in core temperature and the best to study. We thought that was a fantastic idea, so we've actually implanted these in 28 of our research horses. And they've had them now for 2 or 3 years, no problem at all. They're put mostly in, we use mostly the gluteal muscle, and we put about 2 centimeters deep into the muscle, so they're not real super deep. It's allowed us to study a lot of things related to how horse muscle, how hot it gets, and how to cool it. Typically what we do in our research situation is either standardized exercise test on our treadmill or at our racetrack. We have horses under saddle that do standardized exercise tests on a 1,200 meter track. And during those studies, we always measure heart rate, we measure respiration rate after exercise, and we measure these muscle temperatures. So this is just a horse galloping on our treadmill, wearing a heart monitor, kind of the normal type of kit for doing treadmill stuff. But here's the same horse having its temperature read, and that's all it took. That it's a normal reader like you would read for measuring IDs in dog microchips or horse microchips. The extra probe was so that you could reach over while they were actually galloping. This is transmitted to this microchip reader, where it's transmitted to via Bluetooth to an app where we can keep track of the muscle temperatures during and after exercise. So this is what a typical bout of exercise would look like. The yellow is the exercise bout. The speed is in meters per second. So this is a typical step test. Go up to 10 meters a second, and then a trot and a walk warm down. The purple is the horse's heart rate. It goes up with exercise. A couple of the blips is when we elevated the slope of the treadmill. Goes up, but then when we start to warm down in a trot, you see that the heart rate recovers back to resting. You can look at the muscle temperature, though. It doesn't recover right when the horse slows down. There's all that heat that's in the muscle that still has to go away. And then after exercise, in this particular case, we walked the horses for 15 minutes, put them in their stall, but you see that they still, after an hour, had not returned to resting. So the horse evolved to use sweat as its main method for cooling, but how can we help the horse when we need to accelerate that, or if you're in a climate with high heat and high humidity where you need to get rid of that quickly? What are the most effective cooling strategies? This has been for a long time and continues to this day to be a really big welfare question about how can we effectively cool horses. And this all started back a big push before the 1996 Olympics, where the Olympics were going to be in Atlanta, Georgia in July. Who thought of that? Thought that was a good idea. It's hot and humid in Atlanta, somewhat like Ocala. And so before, there were some problems that had occurred in Barcelona in the Olympics, so they decided we're going to have a real push, a lot of research to look at these factors, and there was some great work that was done. The same problem was on everyone's minds in Tokyo for 2020, and it actually ended up in 2021, and the JRA did some really interesting studies looking at different cooling methodologies. And basically what they did is they got the horses hot on the treadmill, they measured muscle temperature, and they measured core temperature with thermistors, and they looked at either not cooling them post-exercise, using just a fan on the horses, or intermittent cold water with scraping and without scraping, and they also did a standing wash. And now they weren't exaggerating when they said standing wash, because this is the Mac Daddy of all standing washes. This is how they put water on those horses. And they've actually, the JRA has adapted this technique now around the JRA exercise courses. So that was when they put a lot of water on. This was changes in blood temperature that they measured. The gray is when they didn't do anything to the horses afterwards. They got them all up to about 42 degrees C or 107 Fahrenheit. And you see the the gray line's the highest, where they didn't cool the horses. And then here's one where they just put a fan on, putting the intermittent water, but you can see when they did their Mac Daddy standing wash, it really did a great job. And I think it really demonstrated just how good putting water on a horse is for cooling it. And we've discovered that too. Really, putting water on a horse is 25 times more effective than just having conduction via air. So I'm a big fan of hosing a horse. It's a very good thing to do. This is a study we did where we looked at the same horses where we were walking them only, or whether we hosed them for 5 minutes and then walked them. And you can see post-exercise how much difference, and that was just 5 minutes of hosing, did on their ability to recover from exercise. We've done thousands of these now, and every time we do one of these tests, we measure the post-exercise cooling every 5 minutes. So we've got a ton of data about how horses cool. And one thing we discovered is heat dissipation acts like drug elimination. It follows an exponential one-phase decay. And so because of that, you can log transform it, and you can create a cooling half-life. And this is great because then we can use that information to see how well is the horse cooling with different types of methodologies. This shows some of the experiments, kind of a consolidation of several experiments we did where we either hosed the horse for 5 minutes and then walked him for 10, or hosed him for 5, or just walked them. And this is the gluteal temperature. And so in this particular exercise, we didn't get them super hot. It was 105 degrees Fahrenheit. But I think this really nicely shows how putting water on a horse, how you can see that drop in muscle temperature every time you put water on the horse. You also see that same effect in respiratory rate, and it's even multiplied though. And actually, I'm not sure that this is really a good thing, but the reason this is happening is when you put water on a horse, it's cooling the horse. That, as the blood is cooled, is telling the brain, I'm cooler. It's not the muscle telling the brain, it's the blood telling the brain it's cooler. You don't need to have a high respiratory rate anymore. And so they'll reduce the respiratory rate, and I'll show you in a second where that might not be a great idea. But again, when we did this experiment where we looked at all these different methods of cooling, we about halved the half-life, the cooling half-life, by either of those, either hosing them first or hosing them second. But the cooling half-life went from 32 minutes down to 15 or 16 minutes. We've done the same sort of studies with our horses under saddle at the racetrack, where in this particular experiment we have 8 two-year-old thoroughbreds that we did what would be kind of a typical mile training gallop. And we looked at how hot the horses got during exercise, and then how well they cooled with different types of cooling modalities. And when we first put this into these horses, it was a real eye-opener, because we had kind of considered, you had a standard procedure. You bring them in, you hose them off a little bit, you walk them around, and you put them in the stall. And we're putting them in the stall, and we realized, well, their muscle temperature is still 39 degrees. So we weren't seeing how hot the horses actually were. When we tested a lot of these different types of cooling methods, though, this is a picture of one of the two-year-olds being hosed. We found that definitely adding water to the horses, or cooling the horses with water, was very important. Here's Ryan taking a muscle temperature. That's the nice thing about this methodology, is it's so non-invasive. You can just put it up there and off you go. But this shows how well just hosing the horses for 5 minutes, how it changed their ability to cool. And in fact, in that particular experiment, the horses cooled 3 times as fast when we hosed them for 5 minutes than when they were walked alone. Now we've added an extra layer to this, and in this particular experiment, we looked at on the bar on the left, the horses were hosed for 5 minutes after exercise. These horses were just walked. So you already got an advantage of hosing the horses during the first 5 minutes. But then the next 10 minutes, these horses were put on this walker without any misting. The ones on the left, we turned the misters on. This is used for irrigation in our walker, and it made a big difference. So walking the horses or exposing the horses to a fan with misters makes a big difference. It's an important way to cool horses, and this is something that we've known for a long time. Because this is a picture I took in 1996 at the Atlanta Olympics, and they had misting fans. This has become standard issue at any of the Olympics. After cross country, they have, you can see the mist in the middle here. This was Atlanta, this was Athens in 2004, and this was Hong Kong, the Beijing Olympics. They all use these misting fans now, so it's a great idea. So what's the most effective methods? Here are my top 3. Continual hosing. Water's cheap, put it on, do a lot of it. Scraping doesn't really matter if you continually replace the water by hosing them. Misting fans are very nice if you have them, or just high velocity fans. Air doesn't do a very good job of displacing heat if it's just standing still. If you move the air and you replace it with cooler air, the heat can dissipate. Now there's a special class of horse that we've had the opportunity to study a little bit, and that's one with anhydrosis. And anhydrosis is horses that don't have the ability to sweat, which is a pretty big problem since that's how horses evolved to keep cool. So these horses are in a world of hurt when they can't sweat. This horse is wearing some patches that is undergoing a terbutaline dilution test. And this was a test that was developed at the University of Florida. Sally Donata, who's in the audience, hi Sally, did these tests for us. And basically there's different dilutions of this terbutaline that's injected. You measure how well it produces sweat, and you can quantify how well the horse sweats. And so it's on a scale from 0 to 5. 0 is a free sweater, 5 is full tilt. Anhydrotic is what I was trying to say. And it turns out in our research herd that we actually have some horses that are 4s out of 5 that are almost anhydrotic. And I thought I'd show you a couple of slides here that are sort of interesting about how they actually behave. So the red horse here is one that's a 4 out of 5 anhydrotic, and this is a bunch of our other horses that are normal sweaters. And this is the respiratory rate before exercise, respiratory rate right after exercise. And you can see this anhydrotic horse has a really high respiratory rate because that's the only cooling mechanism it's got left. It doesn't have the ability to cool with sweat, and so it really ramps up its respiratory rate so it can cool. But look what happens when we hose it. In 5 minutes of hosing, that horse's respiratory rate returns like it's a normal horse. The problem with that is its muscle didn't cool down like it's a normal horse. So I think if you have an anhydrotic horse and you hose it, you need to keep hosing it because you've taken away its ability to get rid of heat via respiration. When you put a water hose on, hosing is great, but you need to keep doing it longer if you have an anhydrotic horse. Now, finally, I'm going to talk about, are there any nutrients that can affect this? I talked about management up to now and putting water on. And as luck would have it, one of the nutrients that seems to be very important in this is vitamin E. So as Carrie set this up very nicely to talk about vitamin E. And we discovered the importance of vitamin E in this cooling process really accidentally. We're presenting some of these data, or we've submitted these data to be at the next ICEEP in October. But what happened was we were doing an experiment with our regular research horses, and we were asking some questions about oxidative stress. So we were measuring indices of oxidative stress and happened to be measuring vitamin E at all. And what we found is these 7 horses ended up going into really different phenotypes, how much heat they produced. We had 4 of the horses, and this graph shows the sum of 2 different SETs. You can see that the horses that were cool, their muscle temperature came up and then they cooled. These horses, the hot phenotype horses, there were 3 of them, they got really hot, and it took them a much longer time to cool. These horses were fed exactly the same, they're trained exactly the same, they're kept in exactly the same environments, but they showed this really big difference in their ability to cool. When you looked at their heart rate, it became sort of puzzling because their heart rate response during exercise looked very similar. Where they started to be different is post-exercise. So post-exercise heart rate remained elevated in these hot phenotype horses. We measured lactate and glucose in these horses pre and post-exercise, and that's where things started to change. We saw that the horses that ended up hot had elevated lactates post-exercise, and they also had elevated glucoses, which was kind of peculiar. But the thing that was really striking, and we found this again accidentally, when we looked at these horses' vitamin E level, and this was their resting serum vitamin E level, and we compared them to how hot they got during this same exercise, they bunched into these 2 different groups. And all of those red ones are the hot phenotype. All of those horses had vitamin E's below 4. And so we've been talking about some of these thresholds of being 2. Well, I'm talking about a threshold of 4 in this situation. We looked at serum vitamin E not only pre-exercise, but we also looked at vitamin E post-exercise and took measurements across time. And this is what we saw with the different horses, with vitamin E, with the hot horses versus the cool horses. I want to reemphasize, though, we hadn't supplemented these horses differently with vitamin E, and all of these horses were getting about 1,200 IUs of vitamin E a day. So they weren't on vitamin E deficient diets, or we wouldn't think they were, and this was synthetic vitamin E that we were supplementing, and they were also on adequate selenium. When we looked at selenium, though, we saw that the horses that got hot were significantly lower in selenium, but if you look at these levels, they're still in adequate ranges. We didn't see a difference in glutathione peroxidase in this particular experiment. As one of the measures that we do for oxidative stress, we do a couple of blood assays that are fairly easy to do and repeatable to do. One's called a BAP test. It's the biological antioxidant potential. And basically, it shows how well the blood plasma can reduce ferric iron to ferrous iron. So it's a pretty cheap and cheerful assay to look at biologic antioxidant potential. And on the flip side, we look at DROM, derivatives of reactive oxygen metabolites. And what this is measuring is the circulating hydroperoxides that are in the blood, and those are end products of reactive oxygen species, and it's kind of a mixed bag. But when you look at these 2 together, the ratio BAP to DROM, you can use it as a sense of oxidative stress. And you see on the right-hand side, those horses that were hot had a lower ratio. A lower ratio suggests they had higher oxidative stress, or they didn't have adequate antioxidant capacity. So if you look at how do horses get oxidative stress, a lot of it happens in the mitochondria. So during regular active aerobic metabolism, there's the production of quite a few reactive oxygen species, and these are oxygen-containing byproducts of oxygen metabolism. In many cases, they're normal. They're a consequence of oxidation, and they occur during respiration in the mitochondria. Where it becomes a problem is when exercise exceeds the production of these during exercise precedes exceeds the ability of the horse to get rid of those oxidative species, and that leads to a state of oxidative stress. And Mike Davis and Warwick Bailey did a really interesting study where they took muscle biopsies from horses, they isolated mitochondria, and they put those in a mitochondrial respirometer. And then they ran the respirometer at different temperatures. And what they found was when they ran it at normal temperatures, they produced some reactive oxygen species, but when they cranked the temperature up, the number of ROS went way up. And so they showed that high levels of heat in the mitochondria increase these the reactive oxygen species production. And interestingly also, they found that once they conditioned the horses aerobically, it actually increased the amount of reactive oxygen species production. So where's vitamin E come back into this? Vitamin E is a really important antioxidant specifically in the mitochondria because it's a chain-breaking antioxidant that protects mitochondrial membranes from this oxidative stress when they're scavenging these reactive oxygen species. So why did our horses that got hot every time they exercised and a lot hotter than the others, why did they have low vitamin E? Well, what we speculate is those horses' muscles got hotter during exercise. We don't know why they got hotter. That's still a question we're trying to answer. But hot horse muscle produces more reactive oxygen species. This causes oxidative stress that requires the consumption of vitamin E to prevent this sort of oxidative, to neutralize these free radicals. And so high levels of ROS, or sustained oxidative stress, we think can lead to this depletion of vitamin E. And so it's interesting because the previous talk about vitamin E, we're talking about horses out on pasture, we're talking about horses with myopathies, we're not talking about exercised horses. And I think that's where it becomes kind of a different sort of deal, that these horses were exercised a lot, their muscle was getting hot a lot. So what was happening that these horses couldn't cool themselves, though? That didn't necessarily have anything to do with what was going on in the mitochondria. This is pure speculation at this part, but we think that what may be happening is those extra reactive oxygen species that are generated during intense muscle work, they might actually oxidize the endothelial cell membranes as well and reduce nitric oxide bioavailability. Nitric oxide is important for the endothelium in the skin to increase vasodilation, to allow that blood to perfuse from the muscle to the skin so it can be released. So if you reduce this dilation, that might limit the ability of the post-exercise muscle and skin flow that led to this higher level of temperature. So that was the first study, and we thought, well, what's the obvious thing you do next? Let's feed them some vitamin E and see what happens. We did that, and it actually, this second study occurred with those same horses, but it occurred a year later. When we took those same horses that were classified as hot or cool, we used them in a 70-day longitudinal study. Day 0, we measured their serum vitamin E again, and we saw, yep, our hot horses were still low. We did an exercise test, and these are harder standardized exercise tests. They go for 52 minutes. The horse muscle gets quite hot. Then we took those hot horses and we supplemented them with vitamin E. And we picked 5,000 IUs of a water dispersible, nano dispersed natural vitamin E. And we fed them that for 70 days. At the end of the trial, we repeated the test. And this shows what happened to the serum vitamin E, and this is a delta here, so this is from where they started. The hot horses actually had a lower level of vitamin E at the beginning than the other horses, but you can see that there was an immediate increase in vitamin E, and then it sort of plateaued off later. Well, we repeated this study, or the standardized exercise test, 70 days later. The horses that got hot still produced more lactate. when they weren't supplemented. Now, if you look at the y-axis, they weren't producing a lot of lactate to begin with. This was more of a long, slow, hot type of exercise test. But when they were supplemented for all that time, they did come back to the same level of lactate production. Now, as fate would have it, when we did the second exercise test, the environmental temperature was a lot cooler than before, so both treatments actually ended up running cooler during the second test. So what we've had to do is compare how both of the groups reacted to the second test compared to the first. And what we found was it didn't make any difference. The horses that were supplemented with vitamin E got just as hot during exercise. But what happened was the first 15 minutes post-exercise, they cooled a lot better. So after exercise, we did have an improvement in cooling. There wasn't an unchanged muscle temperature during exercise, so it doesn't look like we actually reduced heat dissipation, but we improved post-exercise cooling, which sort of aligns with the enhanced convective cooling by better perfusion, blood flow to the skin. And the lower lactates may indicate that we actually increase perfusion to the muscle during exercise. The next step we need to do with this young lady up here, Sarah White, is to take muscle biopsies from these horses, put it in a mitochondrial respirometer, and see how those mitochondria behave outside of the horse, ex vivo, and see is it something with those horses with the mitochondria that's making the difference or not. But at any rate, it seems like there is a difference, and it's explaining some of the differences we're seeing in the vitamin E content of these heavily exercised horses. So what have we taken away from this? Well, our recommendation for vitamin E supplementation, and this is for performance horses in the heat, so it's a little different than the normal acceptable ranges. I think the level of 2 is too low for them. And Carrie, I am also talking about HPLC methods, so I'm delighted that you went through all of that before. We had used Michigan State for years and years and years. We've since switched to Cornell's lab because they are doing HPLC. I think that 4 should be the cutoff for the HPLC method for these horses that are intensely exercised in the heat. We saw that differentiation there, and I obviously think that the water dispersible vitamin E is the way to go. One thing, and my recommendation is to hit them with a big slug of it if they have that low of vitamin E when they're entering exercise in the heat. Go for 3 weeks, 5 weeks, retest, and go from there. But I want to say something here. Not all of the water dispersible vitamin E's are the same. There are a lot of those that are coming on the market, and they're quite different. We've got some on the market. We've got some we're developing on the market that are either nano-dispersed or micellular. And so we test the bioavailability of these vitamin E products all the time. Basically what we do is we take a 5,000 IU bolus of vitamin E, a dose of vitamin E, and then we take blood samples for 24 hours after exercise, and we look at the area under the curve for these vitamin E's. And this happens to be from 12 horses that we used. And I didn't put any product names here, but I wanted to illustrate that all of these vitamin E products, product 1 through 4, are all purporting to be the same type of product. They've got the same bioavailability. Synthetic, the one that Carrie talked about, is in red here, is the synthetic. But look at product number 4. It didn't behave any better than the synthetic. In fact, it probably behaved a little bit worse. Product number 4 in their product literature is using product number 3's actual data for validation of what they're doing. And I think that's something where you probably kind of need to keep an eye on. Where are these claims coming from? Has the bioavailability actually been validated in any type of study? I'll crawl off of that soapbox now. Some other interesting things that we're still evaluating in terms of heat recovery are polyphenols, and there was a question about resveratrol before. That is a polyphenol. That's not the polyphenol we've been studying. We've been studying another class, but in a study we did with polyphenol supplementation, we increased the concentration of the activity of glutathione peroxidase, which was kind of neat. We don't know why that happens. In the literature, it says that we may be upregulating genes that are regulating the activity of glutathione peroxidase. That's a question that still needs to be answered. But I think there's a lot of promise using some of these other things. But again, this was affecting glutathione peroxidase. It wouldn't have had an effect on vitamin E. So I think if you're going to use these, they need to be used in concert together. And then finally, we've been getting some neat data using betaine. Betaine is trimethylglycine, and it's an osmolyte. And betaine actually has some very good mechanism of action to help horses retain fluid in their cells. And so during the mild heat stress, you can help maintain hydration, and during heat stress, you can help the cell from becoming downright distressed. The slide that I have on the right was from an exercise test where we had horses with and without betaine. After exercise, we saw how well the horses retained water that they were given post-exercise, and when betaine was supplemented, the horses were better able to retain the water that they had drunk. So we think that this also has some promise as well. So in conclusion, what should you do for horses that are in hot, humid weather? Hose, baby hose. I think that's the number one thing. Misters are a good idea. Fans all the time. Electrolytes, you're replacing the electrolytes. You're replacing the electrolytes that were lost from sweat. You need to understand how much was lost. I think vitamin E is a very important nutrient for this class of horse. And again, the natural vitamin E, check the bioavailability, and then stay tuned for the polyphenols and betaine. I think they're going to become more interesting as we study them more in the future. So thank you very much. I'll stop at that. And try to answer the friggin' peanut gallery down here. Now, I'll have to say that this whole row are PhD equine nutritionists, so whose arms fly up afterwards? You should just give them a microphone.
Hi, Joe. I'll protect you from them for about 30 seconds.
You're segregated. Good.
Yeah. So really nice work. Thank you for presenting all of that. For your study where the horses got the additional 5,000 IUs of vitamin E per day that were your hot horses with low serum vitamin E, am I correct to assume that those horses also had abundant access to fresh green grass and were already on a full NRC adequate vitamin E program at the time?
The horses were supplemented with vitamin E, and again at 1,200 IUs of synthetic vitamin E. That second study that was done in the winter down here in Ocala, so Cary, it's not as green down here in the winter. In fact, it's not very green at all, and the Bahia pasture goes away, and the vitamin E sort of goes away. The horses were kept inside for about 18 hours a day, but then they had access to that dead Bahia pasture, so I don't think you would say that they were getting abundant pasture during the study.
Joe, great talk from a nutrition and a feeding management perspective. Thinking about feeding forage prior to exercise, how does any of that come into play when we think about fermentation and heat production in the horse relative to any of the research that you've done from an exercise?
Yeah, that's an interesting question, but it's almost a different question because I was focusing specifically on heat produced during exercise, specifically in the muscle. There is other heat stress, and some of that heat is coming from the environment and radiation and that sort of stuff. So I think fermentation at that point is a relevant topic, where normally we think of that during the winter as being a good thing. I don't know that there is so much heat produced in the muscle that is probably a relatively small factor compared to how much heat is being produced. I mean, it's a massive amount that they're having to clear. Sarah.
Of course, I'm obsessed with selenium. So I found that the one data point you had very interesting, because we've definitely shown selenium increases mitochondrial capacities in horses. And so have you considered looking more into that side of it as well, maybe dual supplementation of vitamin E and selenium?
Yeah, well, the problem that we've got when we're doing these types of studies, I had an N of 3 and 4. And when you start to ask multiple questions like that of, is it going to be multiple nutrients, you may very well be right. It could be that selenium also played a role. But for that particular study, we asked a single question of just vitamin E. We assumed that the level of selenium in the diet was good. And if you will use whole blood selenium as an indication of status, they seem to be in relatively good status. So I mean, it's a valid question, but it was just a little too much for us to ask.
What was dietary selenium on that one?
Oh, gee, I'll have to look, but it's 2 or 3 milligrams a day, I think.
All right, so my question, and I think you almost alluded to it, but when you had these horses have the respiratory rates drop so quickly, did that do anything, or did you consider looking at EPOC or lactate sort of following that? Because if their respiratory rates are dropping so low, does that change some of the other post-exercise mechanisms that you want?
Potentially, but I mean, normally when lactate's being dissipated, it's because it's being removed by the muscle from perfusion. And I don't know that you're really knocking that down as much as you're knocking down the ability of the horse to remove heat by respiration. And so, like I say, that's something that a normal horse does, and almost anybody that cools a horse uses respiration as their indication of when they're cool. I mean, that's kind of how you decide if a horse is cool or not. But in these anhydrotic horses, I think that needs to be questioned, because that, again, literally is they're panting. That's all that they can do. And taking that away from them, you better replace it with even more water, was sort of the point.
Okay, thank you. We have one over here.
Hi, Joe. Apparently I'm sitting in the wrong part of the room. I should be over there. So as somebody that lives in a climate where 2 summers ago we had 150 days over 38 degrees Celsius, and 50 of those were over 43 degrees Celsius. So for those in the room that work in Fahrenheit, that's 50 days over 110. And where water is not cheap, if we're hosing our horses to cool them down after exercise, or even just bringing them in from a pasture because they come in dripping in sweat just from standing in a pasture, if we've created the sense of illusion that they've cooled themselves down because their respiratory rate's gone down, would you suggest that they then should be in stalls with fans and misters?
Absolutely. I think in that situation, I would be very much in favor of fans, absolutely, but maybe misting fans to replace that. And I'd also bring your attention back to that slide that I showed of Lexington, Kentucky, and you should consider relocating there. It's a much nicer climate than you just described. 2 more questions.
Hi, thank you so much for the wonderful presentation. I may have missed it, but for the betaine supplementation, what was the dose given to the horses, and what work was that based on?
I believe it was 15 grams of betaine a day.
Okay, thank you. And do you remember what kind of betaine or what the
It's an
supplement type?
anhydrous betaine.
Okay, perfect, thank you so much.
We have one right here.
Oh, last question.
Yeah, Joe, I will argue with you. I don't think Kentucky is that much cooler in the middle of the summer, having worked outside on your farm there. So she stole my first question, but my second is, when you did the work on the betaine, were you using normal horses or anhydrotic horses for that water retention?
That work was actually done with our young horses that were raced in a racing program. And so we would consider them normal, healthy 3 or 4 year old horses that were in a racing training program.